Here's a fun part. They're calling it the eccentric end cap. Eccentric end cap. I think I've typically known these as the eccentric strap, but whatever, it's an eccentric part. So you can see what we've got. Casting, and that, hopefully that's obvious that that's an elongated hole through there. So there's a bit of machining stock to be taken out. So the general method of approach of things like this is to drill and tap these holes in the as cast part, so that you can maintain alignment of those. Then cut it, take out whatever machining stock is needed to make this surface flat, bolt it together, and then bore this hole, and that way you can get this hole right on center, so that when you split this, there's no, the parts come together and can go over their mating part easily. We will also need to machine the thickness, and that will be done after separating this again, so that those two faces can be made perpendicular to the bore. And then on top of that, we've got a through hole here with a oil hole going through to the bore. I'm going to move that and put it out here. That will be easier to access. And side benefit to that is that it will provide easier access to the set screw in the mating part, which is the eccentric here, to make timing adjustments easier during assembly. Let's see what else. We'll finish this top surface, and I may try and go in and clean out this surface as well, run an end mill along that, side mill it, just so that we get a clean surface, because there's a shaft comes through here and there's a nut both sides of this to tighten it down, so it's nice to have a machined surface for that to sit on. So that's the part. I will try and do a short video this time. Everything seems to take a half an hour. I'd like to get this under 20 minutes. Maybe that doesn't matter. Anyway, thanks for joining me. Part is clamped in the mill here. To get it set up, simply aligned it using an engineer's square to get it visually vertical. Did a couple of quick checks with a DTI to verify that this all matched what I'd measured. Previous to setting it up, I've measured the rough diameter of the hole, and that looks like I've got 100 thou to come off on the diameter, and about 50 thou that can come out in the gap, 50 to 100 actually. This face is slightly higher than this face. This is all reasonably centered. So the plan is to clean up the top. Then I will clean up these two faces and make sure I do a spot face that will allow for a 1024 nut to spin there. And then we'll slit this. And this is set up in this way so that I can get in here with the slitting saw all in the same operation, so that this split is parallel to these faces. And that one is less critical, it's parallel to that, but that's visually will make it all work. So there we go, we've got 7/16 end mill in there. This is rather a long distance of unsupported material, but I think if I take light cuts with a small diameter mill like this, I think I'll be fine cleaning that up. The other thing we can do at this point is put the through hole in that top boss. Oil hole I'm not going to put here, as I said before, I'm going to put on one of these sides. That'll be in another operation, but should be able to take this all the way through slitting, including drilling and tapping the holes through here, all in one setup. Then it will be a case of repositioning it, getting these two faces machined, and there's only about 10 thou a side that I've got to clean these up to hit dimension, Plenty of material in here, which is nice. But that's the plan. So on we go. There is not enough clearance for my drill chuck to get in and get down to this surface and miss this. So I'm using an ER11 collet chuck to give me the clearance for this next operation. So slightly more awkward in terms of changing drill bits and so on, but means I don't have to alter the setup, which is fine by me. I have a slitting saw mounted in here, and I'm just using a feeler gauge to establish the location of the slitting saw on top of the part. Then I can make a calculation to take half the slitting saw thickness, move down to the center line of the part, and cut through. Here I'm just using an end mill to machine off the faces of the bottom part of the eccentric strap. Just get these two faces coplanar and cleaned up. And the same for the top part of the eccentric strap. Now this is a bit of an unorthodox setup, but what I have to do now is machine this side and the opposite side and the bore. I'm very happy with how the two halves have come together after machining off these faces after splitting them, and it's honestly difficult to see any part line in there. And so I'm very happy about that. Having bolted the two halves together, I went back over and just cleaned up some of the casting on the on each side of these bosses, just to blend those in a bit. And now I was wrestling with the idea of how to set this up, because I have to machine this whole surface, so it's difficult to hold on to the thing. And as I was playing around, I thought, well, I can just use my 4-jaw chuck off the lathe, so that's what I've done. If I had one on my rotary table, I would have used that, but I don't actually have a chuck for my rotary table. Although as a result of this messing about, I'll probably get one. Anyway, part is clamped, and I've indicated around, and I've set up this face. I've used this face, this machine face, to indicate the part. As you remember, that was machined while I was machining these bolt holes and splitting the part. So I know that face is parallel to the split face, and I'd really like these surfaces to be perpendicular to the split face, so that's a good reference surface to use. So it's a bit of an awkward setup, but I think it's solid. I've been careful not to clamp it too hard to put this out of round, but boring the hole will be done separately. What I want to do now is just get these faces parallel. Once I've got those machined, then it's going to be very easy to clamp this part solidly to machine the bore. So another setup, but whatever. Now I've measured this. I need to end up at 1/2 inch thick, plus nothing, minus 5 according to the drawing. Here the part is 20 thou over, and over here the part is about 50 thou over. So I'm basically going to go machine until this cleans up, and then take off 10 this side. Then I'll turn it over, get it securely set up on that nice machine surface, and take it to thickness, and that should balance out then relative to that center. Right, enough yakking. Second side. This has worked. Setting up to get this ready was much quicker than the first side, because I was able to just set that machine face down on the parallels, and when I did it, this face is came in perpendicular straight away, as it should have done, and all I had to do was then clock the chuck around to get it square that way, which in retrospect didn't actually matter at all, but glad I did it. Actually, it will matter, because I might put a small end mill in and dust off the back side of this now. But let's get this to thickness. So I've got only a few thou to go at this point, and roughly 20 or so over there, so I'm just going to lightly skim it. And I'm deliberately using a small diameter end mill, by the way, just to minimize load on this thing and take very light cuts, because this is not a super rigid setup, so I don't want to go at it with a big end mill. Anyway. .497 and 0.495 is the bottom limit. The eccentric width is 0.502, so I'm going to leave it there, even though that didn't clean up. That's on dimension. Check another place here. Yeah, I could take another tooth out off it, but I would rather have the nicer fit. Yeah, see, it's dead on all the way around. So I'm going to call that good, and that's just what you get with a casting sometimes. But it's cleaned up enough that it will run fine. You know, we're not running raw casting inside where the eccentric will run. So what I'm going to do now is I'm going to put a small diameter 1/8 inch end mill in, and I'm going to dust off this inside surface here, just clean it up so that that is flat and parallel to that, which will just make me happy. It's just a nut seats against it, and I'd rather have a flat surface for it. That should do. Went a little bit far over there, but I'll blend that in by hand, but I've now got a nice flat surface in there. Okay, now onto the boring part. Next setup, getting ready to bore the hole through now. So what I've done is clamped the part on top of 1, 2, 3 blocks, which I've made sure are way wider than the bore that's going to go through. I've got a gauge pin in the end hole here, tightest fitting gauge pin I can. And I've used an edge finder to touch off either side of the gauge pin to find that center line, and then touch off on this face because I measured the distance from this face to the split line on this part. So I can now accurately position the center of the finished bore relative to that face and know that it's centered on the part. Before I did all this, when I clamped this up, I clocked along and up and down this face to make sure that's square to the various axes of the machine. So next step is to get the boring head in there and set up and start making light cuts. Got the table locked. Center of the spindle is over the center of the part, reference to here, and boring head is installed, and I've moved the head to a position where I think I'm going to make a light skim as I go through. So we'll take a first pass, and then I'll gradually index the boring head out this way until I start making a complete clean-up cut. I know I've got about 100 thou on the radius to take out in order to get where I need to be, so I can safely go until I clean up, take a measurement, and then start honing in from there. So we'll see how this goes. Now, how do we feel about speed? I think we feel good about that. I've opened the bore up to 1.4215 at the moment, and it's just a matter of indexing the head over using this graduated screw. Now remember, when you're using one of these, if you've never used one before, this will add 1 thou at a time per division to the radius, so bear that in mind. It's easy to get caught out and think that you're adding to the diameter, and you can very easily overshoot, so just remember that's always on the radius. Okay, so I'm just going to keep taking cuts off camera until I get close, and then the last one I'll do on camera. Bang on. 1.501, and we're looking for 1.5 minus nothing plus 2, so I'm there, right in the middle of the range. Absolutely bang on. Very happy with that. Right. Next phase is to release this, and I've got one oil hole to put in at an angle here, and then we'll do a test fit. For this part, it's a simple visual alignment. I found center, front to back using an edge finder, but to get this oil hole positioned, it really just has to go through to the bore, more or less on center, so that I can get an Allen wrench in and access the set screw. So all I've done is I put the drill in there to visually line it up, and then I've got the caliper at 3/4 of an inch, just to check to the center point there, which is plenty close. And there we go. Let's clean that up, and let's go do a test fit on the Eccentric. Okay, I just got done deburring the oil hole. It's a nice clearance for this Allen wrench, which is the size needed for the set screw in the Eccentric. So let's see how it fits. I'll try and do this all on camera. It's a bit awkward. Let's see, got to make sure these are the... Yep, that's correct. So there, like that. There. That was the way it went, wasn't it? Yep. Do not like slotted screws. I will be replacing these with studs and nuts in the final assembly, but for test fit and for all the fixturing and whatnot, these are fine. So let's just go for it. Let's just do these up tight. See how we are. Okay, moment of truth. Well, that feels just fine. There's just the right amount of clearance. Did those up tight, no binding. That makes me a happy model engineer. That's what it's all about. A bit of thought on geometric relationships, work everything through the numbers, and things fit and they work right. Now I'll be interested to see. This is the bit that had a little guesswork in it. Let's see if this works. It should be around there. Man, how tight do I need to do that? Yeah, of course that won't reach. Okay, well I did the set screw up way too tight, but that works. I can get in there and engage with the set screw. So when I'm setting up the timing on this, that will make it a little bit easier. I won't have to completely take that apart to get at it. So absolutely brilliant. Absolutely brilliant. I am pleased as punch with that. The last engine I made, all of these kinds of assemblies, I'd tighten them up and they'd just bind. Either I didn't have the dimensions right, or things weren't square, and so you had to wear the whole thing in order to get it to run. But this hopefully puts me on a path to having this engine just run right off the bat. Very good. Well, again, thanks very much for following along. Hope you enjoyed that. Couple of unorthodox setups, but you have to make use of what you got. But at the end of the day, safely set up, everything correctly in line, and resulting in good parts. So hope you get out to your own workshop very soon, make something fun, be safe, be well, always be the sharpest tool in the shed. Thanks very much. See you again soon.